Welcome to qnawire.
We have a test rocket that weighs 2,540 kilograms. It has a velocity that's given by this expression here. When it starts at t equals 0, when the engines fire, we have an acceleration of 1.5 meters per second squared. And after 1 second, we have a velocity of 2 meters per second. Now, these two conditions here allow us to find these coefficients a and b. So velocity at 1 second tells us that a plus b has to be 2. And I should probably not put units on here because we're yeah, no, that's all right. So let's see here. We have then that a equals, and then the acceleration, we can take a time derivative of that and get this. So the acceleration at 0 is just a, and that is 0.5 meters per second squared, and then that tells us that b or 1.5, and then that tells us that b has to be 0.5. All right. So let's see here. Now we have, and this should be second squared. That's what I was getting. All right. So now they tell us that at 4 seconds. Well, they want what is? Let's see here. So we found those coefficients at 4 seconds after ignition. What is the acceleration of the rocket? Well, we can just, now that we know a and b, we can take the time derivative of that. Here's the acceleration here. Plug in a and b and plug in t equals 4, and we get 5.5 meters per second squared. And now we need to figure out what thrust does the burning fuel exert on it, assuming no air resistance. So the thrust is doing a free body diagram of here, and again I should put our acceleration in here, so we have some acceleration there. So we have, after a little algebra, we get that the force equals the mass times the acceleration of the rocket plus the gravitational acceleration. Now obviously we could just plug this into here. I assume that they meant that the force at 4 seconds, and so that tells us that we have 3.89 times 10 to the 4th newtons. And then they asked us to give it as a function of, or in terms of the weight of the rocket. So we can just divide by the weight of the rocket here. So the that is 1.56 times the weight of the rocket. So obviously, because it's greater than the weight of the rocket, it's going to be accelerating upwards, and that's in fact what we know it is doing, because we have a positive acceleration here. Then they ask us for the acceleration, the force at ignition. So we know that is a acceleration is just the coefficient capital A here, which is 1.5 meters per second squared. So we can plug in capital A here, add g to it, multiply it by the mass, and we get that is 2.87 times 10 to the 4th newtons.